Hello everyone, I'm very glad to have the opportunity to make this presentation. I'm Yiwen, a second-year master student from National University of Defense Technology. As we all know, Docker is one of the most popular containerization tools in current DevOps practice. It enables the encapsulation of software packages into containers and can run on any system. Since inception in 2013, Docker containers have been downloaded 130 billion times. The annual Container Adoption Report found that 79% of companies choose Docker as their primary container technology. Recently, the frequency and impact of build failures have been quantified in many contexts. For example, C++ and Java builds, Ruby builds, and continuous integration builds. Docker builds often break too, and a large amount of efforts are put into troubleshooting broken builds. However, little is known about the failure frequency and fixed effort of builds in the Docker context. So, our research target is, what is the failure frequency and fixed effort of builds in the Docker context? The figure gives an overview of our study. Our data collection involves mining two types of sources, GitHub data and Docker Hub data. We present an empirical study of 857,086 Docker builds from 3,828 GitHub open source projects. More specifically, we attempt to answer three research questions in this paper. The first RQ aims at understanding how often Docker builds fail. The figure shows the distribution of project-specific build failure rates in our context. Specifically, in this study, we compute the overall rate of build failures and project-specific rate of build failures. We find that 17.8% of Docker builds in our dataset fail, affecting 85.2% of projects. Also, 31.5% of projects have more than 20% of broken builds. We find that the median rate of project-specific build failure is 10.5%. However, frequently built projects are associated with a relatively low ratio of broken builds. The second RQ aims at understanding the time spent by developers fixing the Docker build failures. The figure gives the distribution of resolution time of broken Docker builds. We compute the fixed time as the time interval between the finishing time of the broken build and the creation time of the successful build in the for fixed pair. We find that 4.8% pairs take less than 1 minute to fix. However, 32.5% pairs take more than 100 minutes to fix. The median fixed time of Docker broken builds is 44.2 minutes. We also find that a project that shows presence of large number of broken builds is related to longer fixed time of build failures. This RQ aims at understanding whether the ratio and fixed time of broken builds is a constant value or fluctuates across time. We aggregate our dataset per period of 6 months to obtain the evolution of build failure ratio and fixed time across time. The two figures shows the distribution of failure ratio and fixed time in different time periods, respectively. Overall, we find that the failure rate and fixed time of Docker builds fluctuate and gradually increase across time. As a preliminary study, our work motivates the need for collecting more empirical evidence of Docker build failures. Some initial ideas for further study include: first, we should mine additional contextual data to perform a more detailed root cause analysis of Docker build failures. Next, we should explore the relationship between Docker build failures and potential influencing factors. Then, we should compare the occurrences of Docker build failures between open source projects and industrial organization projects. Finally, we should create sophisticated management tools that enhance Docker build process and integrate with different IDE via plugins. In summary, this study performs a large-scale empirical study of build failures in the Docker context, including frequency, fixed effort, and their evolution. Thank you very much for your listening.